Hi, Physical Science. I wanted to talk to you today about how we determine charges of transition metals when they're in an ion. So, and then how you name them. So, transition metals, they can be tricky and bonding. So, I mentioned on our note slides that these guys down here, my transition metals, can have weird, like, multiple versions of them in ion form. Like, for example, gold over here, it can have multiple different ions going from one, like +1, all the way to like +3. And that can be kind of crazy to deal with, especially going, which one of them is being used or made in our case, okay? In like different cases. So what I'd like to do is show you how you figure out the charge of your gold or like any of your transition metals and figuring out how to name your said compound when that happens. So let's start off with using gold as one of our examples. So let's say you're given the compound AuN. Okay? First of all, you have to look at it and kind of figure out what's the charge on gold to understand if this is balanced or not. So, if I told you it is balanced, what would the charge have to be on gold to make that so? Some of you are crying, well, nitrogen has a charge. And it does. What's its charge? Nitrogen is here in column 15. Has 5 valence electrons, so it needs to 8. Since it's closer to 8 than 0, it adds 3 to get there, so it's a -3 charge. So if nitrogen has a -3 charge, how many nitrogens do we have? According to the blank spot, we have 1. So in total, our charge on this side, our negative side, is 3 times 1, which equals -3 on this side. We can kind of do the same thing now over here on this side with gold and ask ourselves, what charge up here is times by our number down here, which according to the blank spot is 1. 1 gold atom is here. Equals what balances out here, which is a +3. And the answer to that, so what times 1 is +3? And that, hopefully you should think about it, is +3. Which means that this gold has a +3 charge. Now you might be thinking, how is that important? Well, like I said, there can be multiple different types of gold. And when we actually name these compounds, that's really important to know the charge, because we can tell people who are looking at that name and tell them what kind of gold ion it is by writing down gold and putting next to it in parentheses a Roman numeral in the place of the charge in parentheses. So gold 3 because it's a +3, and then we continue with our compound name like normal, which is nitride. And so this is your compound right here. That's the name of it. Now hang on, what if we have like a different number here or here? So for example, if we have a different element, like a different compound called, say Fe, 2S3. This is a little more tricky now, isn't it? Well, what you have to do to determine what this compound is called, or to see what charge iron has, because iron is Fe, you have to figure out your total charge on this side, and then your total charge on this side. Okay? So we know that this is iron, but we don't know what's in this parentheses that we have to put down, and then we have sulfur, so that's sulfide. Okay? So if we look at our periodic table, we find out what we know first. We know nothing about iron's charge, like specifically, but we do know sulfur's charge. Sulfur's charge is -2. The other thing we know is that there's 3 sulfurs right here. So if there's 3 sulfurs, we are basically taking -2 times 3 to get our total negative charge over here, which is 3 times 2, 6. So -6 is our charge on the sulfur side. In order to balance out and keep everything neutral, we have to have +6 over here. You'll notice that the thing we know about iron is that there's 2 of them. So in order to figure out our question mark here, we need to take that 6 times it by 2, because that's how many iron there are, to get our answer. Or sorry, we don't need to times it, we need to divide by 2 to get our charge up here. My bad. Sorry, 6. So we're doing the opposite that we did here. So we did -2 times 3 to get 6. We had to do 6 divided by 2 to get our answer. So 6 divided by 2 is +3, right? This iron is also +3, just like our gold from the above one. But we had to figure it out, like we had to do some very simple math to get there. Okay, so what you write in this is then iron 3 sulfide is the name of our compound. Now let's say I gave you something and said that it's not balanced, and I wanted you to add stuff in there, or add iron to make it balanced, or like say add another element to make it balanced. Okay. So for example, I gave you iron with a question mark here and F2. And I wanted you to figure out what goes here. Simple. You would just have to figure out what your charge is. This here is set in stone. And let's say this was a iron 1. You need to have 2 to have it balanced, right? Because -2, this is a -1, +1, +2. You need to have 2 there. Okay. Or let's say I gave you a transition metal with a polyatomic ion. So for example, like chromium. And it says that we don't know what this is, but we have SO4. Chromium, let's say, is a so we know that this is a -2, and there's only one of it. This is -2 here, +2. There's only 2 things that you could put in here. Chromium, if you don't know the charge of it, because there's multiple of it, this can be either 1, which means the chromium will be a +2, or if you put a 2 here, we'll have a +1 charge. Okay. Let's do one more example where I take a name and you have to figure out how to balance stuff out, or like how to write the compound. So let's take nickel. So Ni2 Ni2, trying to think here. Oh, Ni2O, say. Oh, I'm actually doing the opposite of what I'm trying to do, aren't I? Sorry. Let's say we take a name and go cobalt to sulfide. And we wanted to figure out the compound from that. So first off, you look for cobalt on here and you find its number and its what it's called, its symbol, and you write that down. So this would be CO. We don't know how many there are here, but we do know what charge it is thanks to this. It's a +2. And sulfide goes over here. And we don't know how many of those are here either. Okay. But we do know it has a negative charge, and it's a -2 charge. From here, you have to figure out and kind of think to yourself, how many of each will I need in order to be balanced? Look at your charges by themselves. You have a -2 here and a +2 here. Down here, your cobalt has to be a +2, and this is a -2. Okay, So we could actually look at those and see that they're already balanced together and simply rewrite your equation as so. This is your compound because this has a +2 charge and this has a -2 charge. You don't have to do anything else. Okay? So that's kind of how you use transition metals and charges to figure out transition metal charges themselves, or like determine how many of each you have in a compound when you write it down. Okay? Hopefully this made sense. Otherwise, I can, you can ask for help and I'll do some more examples. Okay? All right. Bye, physical science.